Transformer secondary conductors, Dennis, is C. 240.21C. You know that next size up rule that we had in 244B? It doesn't apply to transformer secondary conductors either. When you run the secondary conductors, you terminate an overcurrent device. You have to have an overcurrent. You have to have conductors rated what? The rating of the overcurrent device. You got a 400 amp overcurrent device. You need to have what? 400 ampere wire. John, looking at 310-15B16, 75 degrees C, 400 ampere wire.
It's going to be 600.
600. If it was my choice, I'm going to do what? I'm going to parallel. Now, taking a look at 21C, guys, look this up for me. Is there anything in 21C that says I have to use a raceway for secondary conductor taps? These are not taps, by the way. These are secondary conductors.
Primary current device.
I think not. So the next size rule doesn't apply. These guys are looking at 240.21. Anything about must be in a raceway?
For the 10-foot rule, there is.
There is something on the transformer secondary conductors?
Yeah, point 3 does.
Wow. All right, we'll look at that in a second. I did not realize that. All right, let's move on. Now, there's a C1. We're talking about secondary conductors have to have a protection at a point of the supply. 241.21C1 says that if you have a 2-wire primary and you have a 2-wire secondary, then you don't even have to have overcurrent protection on the secondary at all, because the primary protection device can provide the overcurrent protection for the secondary. But Eric, this only permission of the primary protection to protect the secondary conductor only applies when it's a 2-wire transformer.
Right. There are some other things in there about delta.
Delta, 3-wire.
2-wire, yeah, leave it like that.
Let's leave it for right now. Why could I do it for a 2-wire transformer, but not if I have a Y system? Can you give us any information on that?
Nope.
All right,
I always wondered about that, Mike. I wish I knew.
Okay, you know this. You actually know this. And, are you ready for this? And listen, the reason is if you have 2-wire secondary and there's a fault to the secondary, all of that fault current load is going to be distributed onto where? To the primary single winding.
Right.
And all of that has to come over to this overcurrent device. If I have a 3-phase transformer where I have a Y system on the secondary, then what happens is there's a fault in the secondary. Well, that fault can distribute over 2 phases on the primary side, not 1 phase. So in other words, it's not a 1-to-1 ratio of a fault. But if you go to a 2-wire transformer, so whatever the fault the secondary is, that ratio will be transferred over not 1-to-1, but they'll be transferred over to that 1 winding on the primary. So that's why primary protection of a 2-wire is fine to protect the secondary. But if you don't go into those applications, I think it's a 3-wire ungrounded delta system. I think allows you to also have that provision, because it's going to be winding fault condition. Okay. All right, let's go to our 10-foot tap rule. I'm sorry. These are not tap rules. These are secondary conductors. Not over 10 feet. Have an ampacity for the load. Got it. Have an ampacity not less than the overcurrent device. Got it. No less than 1/10 the primary overcurrent device times the primary to secondary transfer ratio. And I'm like, what the heck is that? Just forget about that, okay? Don't worry about that. That's if you had somehow the secondary conductors to be only 1/10 the amount of current that the secondary can provide. Well, that wouldn't make any sense. You're going to do that. So we could ixnay that baby right here out of there. I didn't see anything about being a raceway. Is this the one that says C2 about a raceway?
Yeah.
All right, so we need to add that in there that it be in a raceway.
It's C3, actually.
Oh, is it C3?
So it's
Yeah.
C2,
3.
number 3.
Oh, C2, the number 3.
C2, 3. Right.
Okay, is this a C2 right here? Is this a number 1 or 2 or 3? Ampacity? What's this?
Number 1.
The C21.
Okay, so this is 1. This is
Actually,
1.
there's a 1 sub A and a 1 sub B
Okay.
is what we've got.
Yeah.
We'll look at that and make sure that we get these things properly numbered. All right, that's it on that one. We're not going to go any further on the secondary conductors 10-foot. If you have outside transformer conductors, just like the outside feeder conductors, right? Dennis, here's what you were talking about.
Yes.
And that was the same rule. You have to terminate a single overcurrent device set of fuses to remain outdoor except the point of termination, have a disconnect located nearest the point of entrance. And again, why unlimited lengths? Doesn't really matter. I mean, it's because it's not inside of a building. It's not going to cause a fire. And that's the key there.
And on this, we were reviewing this last night, and I asked Mike Culbreth about this. One thing I noticed that I picked up on was that it was a 4-conductor. going from the transformer to the disconnect. And what Mike Culbreth turned around and said, because the transformer is customer owned, we can do that.
Right.
Why not can we do that? We have to do that.
Right, we have to do that.
If this is a utility, now watch this. If this is a utility, then 240.21 doesn't apply.
Correct.
Right.
Why?
Because falling power.
Anybody know why? Why would 240.21 not apply if this is a utility transformer?
Because the utility is not governed by the NEC.
No.
Those are
Why do
service
these
centers
conductors do not apply to 240.21
It depends where the service point is, but even so,
Let's say
it's
this
a
is a service.
conductor.
Let's say the service point is right here at the transformer.
It's a service conductor.
Right. These are service conductors.
Right.
Right.
They're no longer secondary conductors of a transformer. These are service conductors, and we have to go to 230, Article 230 for the requirements of underground service conductors and overcurrent protection, and what are the rules on service conductors. Very similar, because the rules on service conductors are what? You have to make sure that they have a disconnecting means nearest the point of entrance, right? That's basically it. Terminate a single overcurrent device? Well, they don't terminate a single overcurrent device, so. They don't. So that's why this would have to be a graphic of a customer-owned transformer, because that's the only way you could have 240.21
Right.
That's right.
All right? How about if you go not over 25 feet? Well, it's going to be just like like the feeder, but these are secondary conductors from this point right here. These secondary conductors not more than 25 feet. Great graphic here. Not less than 1/3 the amp. Okay, have an ampacity not less than the primary to secondary voltage ratio multiplied by 1/3 the rating of the primary overcurrent device. That is so confusing. What we're saying is that as long as these wires are at least 1/3 the rating of the secondary current, then you're going to be okay. Well, nobody puts a transformer and run conductors 1/3 the rating of the secondary current. And terminate a single overcurrent device to limit the load to the conductor ampacity. Of course, it's 25 feet.
Mike,
Yes,
the place where you might see that is if you have one transformer feeding 3 or 4 panels.
absolutely right. And that would be another, yeah, that's a good point. If Mike had this coming out to a junction box and supplying another panel out of here, and now we're going to have what? These conductors are secondary conductors. Well, then, let's say we evenly divided it up between the two transformers, right? I mean, between the one well, then that would be 50% of the current. That'd be 50% of the current.
Right.
Well, then you're okay, because it's at least 1/3 the rating of the secondary current.
You brought up an interesting point there. It's probably not going to be a junction box. It's probably going to be individual raceways running to the panels, because each of those transformer secondary conductors must go from the secondary of the transformer to the panel.
What I meant by a junction box,
Right. Just for
simply
the
to be able to
raceways.
get the two raceways into that one transformer.
Right.
So it'd be like a nipple here, junction box, and run, you're right, 2 sets of secondary conductors to the secondary terminal.
Right.
Good point. Here's an example. All right, if I have 150 amp main breaker, well, I need a 150 amp wire. We can't use the next size up rule. 310/16, B16. John? Right? 175 amp breaker. We need 175 amp wire. Is that 2 watt?
2 watt.
Okay, we got that done. The deal here was this. You have to locate overcurrent device at the point of its supply, except as permitted in A through, I think it was, I don't remember what it was, A through H or something like that. A through G?
I think it was.
All right. And then we had all the different rules that didn't require you to have you can't have the overcurrent device at the point of its supply when you're on the secondary side of a transformer. Sometimes you have to make feeder tap rules. You can't have it at the point of its supply. So that's why but when you do that, you have rules to be able to accommodate that to make sure it's safe. Anybody last comments? Steven, you want to say something?
I might have just got lost on that last one. If you go back to that last slide for
Yeah.
a minute. There is a stipulation that the secondary conductors terminate into a single circuit breaker set of fuses that limits the load current to not more than the conductor's ampacity.
Right.
So if we're going to feed more than one panel, we need to have a breaker and then tap from there, don't we? Am I reading that right?
No, well, good point. The answer is no. You can have as many secondary conductors as you want, actually. Each set of secondary conductors must terminate into an overcurrent device, but you can have 4 overcurrent devices
Okay.
coming off the same secondary.
You guys with that? You okay with that?
Yeah.
Yeah. So your transformers can supply multiple secondary conductors, and each of your secondary conductors have a set of rules. No less, if it's 10 foot or less, no less than 1/10, and if it's 25 feet, up to 25 feet, no less than 1/3, and all the other conditions inside here. So, yeah. It's like a generator. There's no limit to the number of feeder conductors. No limit to the number of transformer conductors, except the 1/3 rule for 25 feet of the 1/10 rules. I mean, you could have like 10 different sets of conductors going out, as long as you size it 1/10. And there, by the way, on that secondary thing, there's not limited to 6. Some people think, well, you have no more than 6.
Right, they're not
se-
service.
Right.
Yeah, it's just a feeder, so there's no limit on that.